Okay. Right, so for the first part, I ask for the I and j for this vector here, and I tell you that this angle is 30 degrees. And this is vector A. So when I look at this, I have this piece here, and this piece here. I'll call this x, and I'll call this y. So I know that cos 30 should equal x over 3, and that sine 30 should equal y over 3. So that means x equals 3 cos 30, and y equals 3 sine 30. Yes, 3 root 3 over 2, and 3 over 2. So that means this vector here is 3 root 3 over 2i plus 3 over 2j. So that's the answer to the first part. Then it really continues like that for the rest of the question. They're all the same. They're just different angles and sides. The only thing I would say is later I ask you to calculate AB, and not that I'm trying to trick you, but I'm trying to get you to see that you already have the answer, because AB is B minus A, which is the answer from part B minus the answer from part A.
AB is B minus A?
Yeah.
Not A minus B?
Yes. No. B minus A.
So AC is C minus A.
Yes. You have that?
Yes.
Yeah. Any other questions from it? No?
Can we do one of the number 6?
No. Delete number 6. I didn't cover with you in class because it's not on the exam. They only ever would ask maybe for the angle and the magnitude for I and j in 2 dimensions. They don't cover for 3 dimensions. So you can just delete it. It's more likely in the physics exam that they would ask you for the magnitude and direction for vectors.
Do it for them.
And for physics it would only be 2 dimensions, not 3. Okay. Okay. Can I scroll down? Not yet? Come on, hurry up. Who's still writing? No, I can't scroll down. Okay. So we're going to have a look now. I mean, we talked about this a little bit in the last class. Magnitude and direction. Now, if I Google here, I'll show you a nice picture. Nice picture. I guess this is as nice as it's going to get.
This is the nice picture?
As I said, as nice as it's going to get. Now, when we talk about direction, we mean angle, don't we? And that's easy to do when it's in 2 dimensions. So for example, here's our vector in 2 dimensions. So if this is xi plus yj, Oh yeah, thanks for pointing that out. xi plus yj. This here is the direction. What would be the formula for the direction here? It's tan inverse y over x. Because this will be x units, and then this height is y units. And this is what I was saying, Ali. In the exam, they would only ask you for the direction in 2 dimensions, because in 3 dimensions it's more complicated because you have 2 angles, which is what I was trying to show you on the Google image. I'll go back to it now in a moment. You got that? So if I just switch back to this Google image for a moment. Do you see here, you know they say X, Y, Z, but it really should say I, J, K. You see the way on the diagram they have 2 angles. There's one angle along the ground in this picture, and then there's one angle up in the air. So you need 2 angles. If you think about like a cannon or something, it first has to turn a certain angle, and then it has to elevate or decline another angle. And this is too difficult for the exam. So we won't worry about direction in 3 dimensions, just direction in 2 dimensions. But we can calculate the length in 3 dimensions, because the formula is so similar for in 2 dimensions. Here, what's the length of this? It's square root x squared plus y squared. And oh yeah, sorry, forgot. The length here, the magnitude is square root x squared plus y squared. And this is in 2 dimensions. In 3 dimensions, that's all. That's all. So it's practically the same. Let's have a look at some examples now using these formulas. Okay, can I scroll down? Yep. Okay, let's have a look at some examples now. So, here is O, and there is vector A, which is, let's say, 5 and 12. What's the magnitude here? It's square root 25
minus 100 plus 124.
Yeah, which is square root 169, which is 13. Now let me draw another vector here. Let's say this one is B, and let's say, I need to make some space. Let's put our B in. So let's say B is 3, 4, and A is 5, 12. Okay, what's the magnitude of B?
B is 16, 9.
Yeah, 9 plus 16. Which is root 25, which is 5. Now what I want you to do for me now is tell me the distance between A and B. So I want to know this distance here. Oh no, you try, don't do anything, you try. I'll show you how to do it in a minute. But I want you to try yourself first. Give me the distance between A and B. Okay, any answers yet?
Well,
I don't think so.
2 times root anything?
Give me the decimal. Roughly. I think you're correct. It should be about 8 point something. What did you get? 8.2. Yeah.
8.25.
Perfect. How did we get that? So Hill, what did you do to get that?
I use A minus B.
Yeah. Why A minus B?
Like B plus
Oh, you were doing so well. Yeah. Let me help you.
okay.
You want to get the length of the vector AB. You want to know how big this vector is, A to B. Now you don't know what the vector A to B is, but you do know what the vector A and the vector B is, or are. So AB is B minus A, and you know each of the B minus A's. So this would be magnitude of -2 minus 8, which is square root of 4 plus 64, which is square root of 68, which is 8.25. Or 26?
246.
Okay, 25. They've asked this one as a short question, section A question. They say, here's A, here's B. What is the length of A, what is the length of B, and what is the length of AB?
How did you do the minus 2 and the
B minus A.
so that's the minus 5.
3 minus 5. 4 minus 12. Yeah? Got that? Okay. Here's my next question for you. We're going to continue using these. So the reason, if you want to break it down into parts, this is like part A, this is part B, and this is part C. My question for you now, I'll give you a minute to try it, it's actually a semester 1 question, is what is the angle here, the theta here? So if I just draw it again, or maybe I'll just draw it a bit bigger here. I'm asking you for this angle here, the angle which is between the OB and the OA. I want to know this angle. That's what I want. I'll give you a minute to try that. Find the angle in red on the triangle. Acute angle, I think it should be. Okay, that should be enough time now. Well, I see people still working. Do some people have an answer? Not yet? Don't know yet. Tell me what you did to get the answer. There you go, yeah. This question here is actually a cosine rule question from semester 1. If you think about it, what's the length of A? What did I say the length of A was? 13. And of B?
5.
And of AB? Yeah, root 68. So as long as you didn't completely forget semester 1, this is cosine rule. Oh, hang on, I better put this in. So we have root 68 squared equals 13 squared plus 5 squared minus twice 13 5 cos theta. 68 equals 169 plus 25 minus 130 cos theta. So this will be 100 minus 126 over 130 is the cos theta. So that means theta is cos inverse 126 over 130. I hope I did all that right in my head. This is nearly 0 actually. It's quite small. 14. Yeah. Yeah. I can scroll down now? Yeah. Okay, let's have a look at another type of problem. So here, I'm giving you this vector, 5i plus 12j, and I want to find the vector which points in the same direction, but is what's called a unit vector. And a unit vector means, let me call it x. A unit vector means its length is 1. So does anybody have any ideas about how I could try and find this unit vector? It's the same as the 5, 12, the same direction. It's just length 1. Any ideas? No? How big is the vector 5i plus 12j? How big is that vector?
5. No,
Try again, Omar. 13. What happens when you multiply a vector by 2? What doubles? The length. And if you divide by 2 or if you multiply by half? Yeah. How? The length half. So if this vector has length 13 and I want it to have length 1, then what should I do? Oh, no. Divide what? Divide by 13. So the answer is 5 over 13i plus 12 over 13j. This vector here will be exactly the same direction, but its length will be 1. And you can check it, because if you do square root 25 over 169 plus 144 over 169, that does equal 1. And also, if you calculate the angle, what's tan inverse 12 over 5? 70 degrees or something? Yeah.
67.
Okay, 67, something. And if you calculate the angle here, you see that it does have the same direction. If you do tan inverse 12 over 13 over 5 over 13, it's the same, 67. So this is how you can make a unit vector. Okay, can I scroll down? Yes? Okay, I'm going to give you two vectors here. Vector A, which is 3, 4, and then vector B, which is, let's say, -6, -8. What I want you to do is get me the magnitude and direction of both of these vectors. And it will be helpful if you want, you can draw it, but I don't need you to. I want the magnitude and the direction. Okay, what's the magnitude of A? And the direction? Could be. How did you calculate it? Sine or tan? No, tan. Tan inverse 3 over 4. No, sorry, tan inverse 4 over 3. What's tan inverse 4 over 3? 53? Okay. Here, what's the magnitude? 10. And the direction? Yeah. Now, are these vectors the same? No, they're different. But what can we say about them? True, that is true. Something else though, although that's true. Their unit vectors will be the same. No, forget about unit vectors at the moment. They're the same direction. What would that mean on the diagram if two vectors have the same direction? Almost. The key word I was looking for was parallel. Yeah. And true, they are opposite in direction here because the minuses, yeah. So these vectors are parallel. Now, you can check if vectors are parallel by checking if they have the same direction. Now, they don't have to have the same direction to be parallel. Is there some other possibility for vectors to be parallel but not the same direction?
Zero.
Yeah.
No, they have the same.
You see, this here is actually not true. It's not 53, but rather I think it should be maybe a minus 53. Because what's happening here is this vector is pointed in this direction with 53.1. But look, both of these are negative. So it's actually pointed in this direction. The 53 is actually here. Now these still are parallel, but they don't have to have the same direction. I mean, this here isn't really 53. If I measured the angle all the way around, what should I add to this to fix it? 180, yeah. But is there another way to check if two vectors are parallel? And the answer is yes. There's a very simple way to check. Two vectors are parallel if you can find a number that when you multiply it by A, it makes it become vector B. In other words, can you multiply A by some scalar that turns it into B? Yes, you're all right. Lambda equals -2 would make A become B. If you can do this, it means it's parallel. And if you can't do it, it means it's not parallel. Sometimes you get this in the exam. They might say, are these vectors parallel? This is the easiest way you can check. Okay. Can I scroll down? Yeah? So vector OR equals xi plus yj. OR is a unit vector. OR has direction of 45 degrees. So I'll give you a couple of minutes. What I want you to do is to find the x and the y. I've given you enough information to find x and y. See if you can find it. Okay, some people have an answer. You sure you have an answer? What's x? For what? Correct, yeah. 0.7 about, is it?
Not 1.
Huh?
Not 1.
Not 1, no. So because OR is a unit vector, the square root of x squared plus y squared should equal 1. That means x squared plus y squared should equal 1. Now, because it's 45 degrees, that means tan inverse y over x should equal 45 degrees. That means y over x should equal tan 45. What is tan 45? 1. So that means y over x should equal 1, so that means x should equal y. If you put that result in here, you get x squared plus x squared equals 1, so this will mean x equals 1 over root 2, or as you said as well, root 2 over 2. And of course y will be the same, 1 over root 2. So the answer is 1 over root 2i plus 1 over root 2j. Now that's only one way to do it. You could have done it from a diagram. If you draw this triangle, how big is this side here? 45. How big is the hypotenuse? 1. And these two are the same, because it's 45, so you could have said x and x. So from Pythagoras you could get the x and you're finished. That's another way to do it. More than one way to do it. So if you look at page 70, in question 1, I don't need you to do the 3-dimension questions in question 1. In question 1, it's enough to do the 2-dimension. You don't need to do question 2, because we did that in the last class. So really what most important is 1 is not so important. The most important ones are 3 down to the end, 3, 4, 5, 6, 7, 8, and 9. And you can see number 9 is, like a section B question, in that it has multiple parts. Okay, I'll let you try these now for a few minutes.